Somewhere beneath the ice of a suburban lake in Burnsville, Minnesota, city workers pulled up something that looked like a prop from a monster movie. It was a goldfish, the size of a football. Not one, but dozens of them. Murky green and heavy, dragged out of Keller Lake in 2021, while the world watched in disbelief. Every one of them started life the same way. Every goldfish does. In a small glass bowl, sold for a few dollars at a pet shop. Somewhere along the way, someone set it free. And that single act of kindness woke up something ancient, because hidden inside the genome of your average 10-cent aquarium pet is a set of biological superpowers that should not exist in a domesticated animal. It can survive being frozen almost solid. It can tolerate toxic waste levels that would dissolve the gills of almost any other freshwater fish. And when the oxygen runs out completely, it does something no vertebrate should be able to do. It brews alcohol inside its own blood. The question is how a fish bred for centuries to be helpless and decorative still carries the tools of an apocalypse survivor. It starts, almost always, with mercy. A hobbyist buys a goldfish from a dealer, maybe somewhere like Kovalpati in Tamil Nadu, and watches it outgrow its tank. Unable to flush a living thing down a drain, they release it into a creek, a storm drain, or a temple pond. In Tamil Nadu, those temple ponds become nurseries, closed and nutrient-rich, where the fish breed unchecked. When the monsoon floods hit, the ponds overflow into rivers like the Tamirabarani, and the invasion begins. But here's what should stop you. The fish that goes in is not the fish that comes out. Goldfish have something called indeterminate growth, meaning their bodies never receive the biological signal to stop getting bigger. Imagine if a human being just kept growing for as long as food was available, until by their 30s, they were the size of a delivery van. That's what happens when a 3-inch pet escapes into open water with unlimited food. Within a few seasons, it swells into a 4-pound juggernaut, nearly 2 feet long. It even sheds its bright orange color, reverting to a murky olive green that hides it from predators. Then it goes to work. Using bony plates buried deep in its throat, called pharyngeal teeth, it crushes snails, uproots plants, and devours the eggs of native fish. It stirs the riverbed as it feeds, clouding the water with nutrients that feed toxic algae blooms. Researchers have found that even the algae itself becomes more toxic after passing through a goldfish's gut. This is not a pet anymore. This is a benthic bulldozer, and that's not even the strangest part. When northern winter arrives and lakes seal shut under ice, oxygen levels crash to nearly zero. Native fish begin to suffocate as lactic acid floods their tissues. The goldfish, though, flips a genetic switch inherited from an event that happened 8 million years ago, when its ancestors' entire genome accidentally duplicated. One copy of a gene kept doing its normal job. The spare copy was free to mutate into something new, an enzyme called pyruvate decarboxylase, the same kind of enzyme found in brewer's yeast. Using it, the goldfish converts toxic lactic acid straight into ethanol and releases it harmlessly through its gills. Its blood alcohol content can climb high enough to fail a roadside breathalyzer test. Its metabolism slows by 75%, and its optic nerves shut down entirely, leaving it blind. For up to 5 months, it drifts through freezing, pitch-black water, essentially a hibernating, intoxicated ghost, waiting for spring. When the ice breaks, it wakes up in a lake with far less competition than before. Eventually, these inland populations grow so large they push downstream, all the way to where rivers meet the sea. Biologists once assumed that salt water would act as a natural wall, stopping any freshwater invader in its tracks. In estuaries like the Vasswaner up in Western Australia, researcher James Tweedley found goldfish weighing over 4 pounds, thriving in water nearly half as salty as the open ocean. Think of that brackish water, not as a wall, but as a highway on-ramp. The goldfish can't live there forever, but it can hold on just long enough to travel along the coast and slip into a brand new river system entirely. It uses the ocean's edge as a bridge to conquer territory it was never supposed to reach. So, how do you stop something like this? In Hamilton Harbor, on Lake Ontario, biologist Christine Boston and her team turned to a strategy that sounds almost like espionage. They capture a large goldfish, surgically implant an acoustic tracking tag, and release it back into the water. This traitor fish swims straight back to the secret gathering points where the population spawns and overwinters, broadcasting its location the entire way. When the tagged fish leads researchers to a shallow spawning bay in spring, response teams move in with nets and electrofishing boats, removing hundreds of goldfish in a single strike. It's the same trick as sending a spy home to reveal his own hideout. Which brings us back to that lake in Minnesota, and the question we started with. The goldfish's fragility was never real. It was a costume, built by centuries of selective breeding, sitting on top of an animal that still remembers how to survive the end of the world. The moment the glass bowl breaks, the costume comes off. What's left is something built from an 8 million-year-old genetic accident, patient enough to wait out a frozen winter, and clever enough to use the ocean itself as a doorway. It makes you wonder what else we've quietly domesticated, thinking we tamed it completely, when really, we just gave it a smaller bowl to wait in. If you found out a pet in your own home carried a hidden superpower like this, would you even want to know?